we will be studying integration and application of integration, which is called areas. So what we do in areas is we're trying to find the area between curves. So let's look at the two types of integrals that we need to set up. Okay, so the first type of integral that we set up is yes, looking at areas, area between curves. Right, so you remember the last time when we did the Riemann sums, we found the area using polynomial functions. Now, what's area between curves? We have two curves and we want to find the area between them. It's not really that difficult. So I'm just going to draw two curves. And the type of integral that we need to set up here. So just say if you have a function like this, right? Maybe a quadratic function, and you have another function which is there. So, and a straight line function doesn't necessarily needs to be quadratic and straight line. It can be exponential and quadratic, any function. So what we want to do is we want to find the area between this, okay? We're going to find the area bounded. When they say area bounded, try to find this area. This is the area bounded. Now, the area bounded between the curve is to take the top function, look which piece will give you the bigger area. So when you're trying to find area bounded, we need to first get the points of intersection between the two curves, all right? So that's a point of intersection, and that is a point of intersection. So we have 2 points of intersection, all right? Which is at A and B. We just need the X values of the points of intersection. So we got A and B. Now, if you're trying to find the area bounded between A and B, you can clearly see that it's the straight line minus it's the straight line area under the straight line function minus the area under the quadratic function. So what we can say is to find the area, we can say integral of y top, the function at the top, y at the top, minus the function at the bottom, right? dx with respect to x, so which is at from A to B. So if I call these two functions like f and g, we can say the area is actually equal to area from A to B of f of x minus g of x, right? dx. Okay, now that's how you find the area. So number one, we need points of intersection. I rather just remember the formula y top minus y bottom. So this is type 1, okay? Now we got two types of, this type 1. Remember first to get the points of intersection. So how you get the points of intersection? We need to say points of intersection first. Points of intersection. Points of intersection we get when f of x is equal to g of x. And obviously you'll solve this equation and you get x equals a or x equals b. So you know where you are integrating from. Next step. The next type of area that we get is something different, type 2. So the second type is we have a Cartesian plane, right? And we have something like this. We have like a quadratic function which is like sideways, right? So this is called basically a parabola, right? I'll just draw a simple curve for now, and I'll just put a line here. Let's just put a line through that point and this point. Or let's go, let me just try to slope the line in different form. Okay, so now, obviously we need points of intersection, but points of intersection where? Now we need the points of intersection on Y. Let me just slant the line a little bit more. Right, great. Now, we still have two functions. The parabola is not a function. Remember, what's a function? Vertical line test must cut the graph once only. So we have two equations. So example, for this one here, we're not going to have f of x. We call this the red function. We call this f of y. Let's call this f and let's call this g. But now the functions are in y and y. So this side function, the f function, is a right function, and this side function is the left function. So where you are integrating is, first you still got to find the points of intersection, but you're going to integrate over dy, not dx. So this is c to d. Should be from C to D. Right. Now, what's the formula? We're still going to find points of intersection. Points of intersection. Rule number one, we find the points of intersection, but how? We call it f of y is equal to g of y. The function needs to be in terms of y. I will explain that by means of an example. Now, obviously, you're going to solve for y equals c or y equals d. And the integral that you're going to set up for area is integral c to d of x right minus x left function. So you're going to take the right function minus the left function. Okay, guys?
Mr. Is this same for the first type?
The first type is top
Yeah,
minus
the first
bottom.
top minus bottom, but
And this is
we
right
still have
minus
to get
left.
points of intersection, right?
Yes, you still gotta
Okay.
get points of intersection.
And Mr. Exactly what area are we getting?
Oh yeah, the area that
The
we're
stuff
calculating
in
here is the
between,
area
right?
bounded. Yeah, in
Yeah,
between,
okay, that
yes.
one. There we go. Okay.
Yeah, that's the area bounded. So you can see the left function is the, let me write x right and x left. So this is x right and x left, okay? And it's from C to D. So it's like a, like a tilted graph,
Wait, Mr.
but
Which one
we're
is
integrating over.
f of y and f of which one is f of y and g of y?
F of y, I will call this, yeah,
Uh,
x
The
right.
red one.
Let's call this, yeah,
X
let's call
right?
this.
Okay. Okay.
And x left, call it g of y,
Call it
yeah.
g of y.
So,
Okay.
yeah, so these are the two types of integrals that we can set up.
So, Mr., aren't
You
these
don't,
technically inverses? They're inverse
yeah,
functions,
yeah,
right?
yeah, it's
Based
more
on an
like,
x-axis, x-y
yes,
axis.
that's
Okay.
correct.
Okay.
Right, now let's solve some problems, guys. All right, so these are the two types of, but remember, rule number one is to find the points of intersection. And then rule number two is to check whether you have top function, bottom function, or you've got right function or left function. That's it. Right, so we have, let's take this example. So we have an example here. Find the area of the region bounded by the curves y is equal to x squared. Let me put this under example one. Yeah. Right? Find the area of the region bounded by the curves y equals x squared and y equals x. So it's easy to sketch this graph. Remember, we always need a sketch and then try to solve. All right, so y equals x squared. Y equals x is just basically a 45-degree line. All right. Why we call it a 45-degree line? Because it passes through the point 1, 1. Right, so if you're going to do 1, 1, that angle is 45 degree. All right, that's why you call it a 45-degree line. Okay, so anyways, okay, so this is y is equal to x. We're not sure whether that's a top function or bottom function. Now we need to check y is equal to x squared. So if this point is 1, 1, right, then let's see, that's 1 there. Now, what about choosing values here for x squared? If I put 0, I get 0. If I choose a value half, I will get half here on the straight line, but on the quadratic function, I will get quarter. All right, so I will get a point which is somewhere around here. Half will give me quarter on the quadratic function. That's how we know that the quadratic function is below the straight line. So if I try to sketch this quadratic function here, you can see. Right, so with this side, it's not important because we are trying to find the area bounded. That's the area bounded. That's how we know that the quadratic, you can't just take this function minus that function. You can't just take the first function minus the second function. No ways. You have to draw it. And you can clearly see that between 0 and 1, the quadratic function is below. So this is the top function, and this is the bottom function. But now if you try to equate both the function, let's see if you can solve the rule number 1, find the points of intersection. So x squared is equal to x. Bring the x over. X squared minus x is equal to 0. X into x minus 1 is equal to 0. You can clearly see there are two x values, right? So x is equal to 0 or x is equal to 1. So that's my A, that's my B value, right? And now to set up the integral, just say area is equal to integral 0 to 1 of x right, okay? Sorry, not right, and top minus bottom. Top function, what does the top function mean? I'm taking this area under the curve of the red line, which is the area of the triangle, and I'm taking the area under the curve of the quadratic function, which is this bottom piece here, right? Area of triangle minus this bottom piece here. Obviously, if I take the area of the triangle minus this bottom piece, I will get the area bounded, okay? So that's why we say top minus bottom. So y top is x. Then let me just write yt minus yb. Yt minus yb, right? Top minus bottom dx. Let's just write the formula down. This is from a to b. So now my integral is from 0 to 1. Top function is x, and the bottom function is x squared dx. And now it's easy to, because we set up the integral, it's quite easy to solve. So let's solve this integral. We add 1 to the power, divide by the same power. So we got x squared over 2 minus add 1 to the power, divided by the same power, x cubed over 3 from 0 to 1. If I substitute 1, I will get half minus a third. That's substituting the upper boundary minus the lower boundary by substituting 0. I'll just get 0 minus 0. That's just 0. And we know half minus a third is, you can put it everything over 6, which is 1/6. Wait, half minus a third, let's see. Yes, it's 1/6 units squared. Okay. Any questions, guys?
So it's pretty simple. I think we did this before. In
Yeah,
we did it
you
briefly in
did.
Introduction to Integration.
Yeah.
And we did it obviously in our exam.
Yeah.
Oh no, we didn't. No, never mind. We didn't do it in our
Yes,
exam.
yes, we did.
We did
All right.
in our final?
It
Really?
was part of the
Oh,
studying process.
yeah.
Right. What about the next one? Next one is quite challenging. So let's have a look at the next problem, right? Right minus left, because first time you're seeing this and you're going to learn how to sketch these types of graphs, all right? But it's quite simple to sketch these types of graphs because you just have to think of the axes in different directions, right? This is like your x-axis, that's your y-axis, all right? This is your x-axis, that's your y-axis. Now, let's take an example of the second type. We have an example here. Yeah. So find the area bounded by something like this. X is equal to y squared, right? Are we good? X is equal to y
Oh, it's
squared.
one question,
Yeah.
so sorry. First the question we're using for the x side and second one for the y side, yeah?
Yes, yes.
For the
correct.
intercepts.
No, but
Okay,
now we
okay.
still don't know which is the right function, which is the left function. Khalas, if we know which is
Yeah.
the right function and left function, we don't even need to sketch the graph. So because we don't know, we got to sketch the graph. But now let me just take you quickly through some basic curves. Remember, if I have a function like this going through 0, 0, just quickly, right? Quick. This is y equals x squared, okay? Going down, y is equal to negative x squared, right? Basic curves. Now, what
Yeah.
about the sideway curves? This is x is equal to y squared, okay? Sideway curve. Makes sense. You can also think of this curve as being y is equal to plus minus the square root of x. So positive square root of x is going up, negative square root of x is going down. Right, nothing difficult here. Right, so you can think of this as the same thing. And the last graph is a sideways function like this. What is this? X equals negative y squared. Good. So these are your four parabola. Okay.
So according to that formula, we can find which one is right, which one is left.
Yeah.
We take another side.
So now obviously you can actually sketch this. This is basics, right? This here you must know from grade 10. This is something different, right? So let me just draw a line. And now now it's easy to sketch this function here, x equals y squared. So we know exactly where we are heading. X equals y squared. Oh, okay, so x equals y squared is a function like this, right? Going up according to that. And what about the next function? X equals 2 minus y squared. So you're shifting the graph 2 up on the x-axis, right? Because negative y squared is here and you're shifting it 2. Are we good? Minus y squared plus 2. Look at this 2 here.
Yeah, okay. This is one question, Mr. Ghazali. So
Yes.
if it will be y, it will be y equals to the 2 minus x squared. It will be 2 points to the upside upwardly, yeah. In that case,
if it's 2 minus x squared, if y equals 2 minus x squared, then is this graph here 2 points up, correct? Now this is 2 points to the right because the way the function is represented, right? So 2 points here and it's a sideways parabola like this.
Okay, great.
Right. So now we want to find the points of intersection here. We got a problem because now that's one point of intersection there, and that's another point of intersection there. So this is C and this is D, and we are trying to find the area bounded here, the shaded area here. Now, just mind the graph. The area doesn't really look like this. If you try to draw the graph more accurately, it should look much more neater than what I've got here. Let's try to shrink this a bit. Right, so rule number one, we need to find the values of C and D, which is the point of intersection. And which is the right graph, which is the left graph. We can clearly see the right graph is the 2 minus y squared. This is the right, and that's the left. Problem solved. So we need to find the points of intersection, which is y squared is equal to 2 minus y squared, correct? X right equals x left. Points of intersection. How do you find points of intersection? You need to equate both, right? You need to equate the left and right function. X left equals x right, or
So
x
I
right
got
equals
x
x.
equals plus minus 1. Oh, sorry, y
Oh,
equals plus minus 1.
We'll check it up.
Yeah.
That's good. That looks like it's correct. X left is 2 minus y squared, and that was y squared. So I've got 2y
2y
squared is equal to 2. Y squared equals 1. So plus minus 1, that's correct.
Plus minus 1, because we
Y is
do
equal
that
to
when
plus
we
minus, yeah.
square root. Yeah.
Yeah. So area is now integral c to d of x right minus x left dy.
dy.
Now you'll see why it is dy, not dx now. Because remember, x right is a function in y. X left is a function, another function in y. So we're going to get integral from -1 to 1. What's the x right function? X right function is, wait. I think I'm mixed up something here. X right, x right was 2 minus y squared.
2 minus y squared.
Yeah, I mixed up this is a right. That's a left, yeah. So 2 minus y squared minus, what's the x left? You gotta put brackets here because sometimes you get, many terms. So you gotta put brackets here. Yeah. So this is y squared. So I'm just gonna put brackets here for now. What if you had y squared plus 2? Right. So now we've got integral -1 to 1, 2 minus 2y squared dy. Now it's easier to integrate this now over y. Now you can forget about everything. You only focus on this integral now. Don't worry about the answers before. So now integrating this, you're going to get 2y minus 2y cubed over 3 because I'm adding 1 to the power and dividing by the same power, right? And we're integrating from -1 to 1. Okay, so now the integral is now equal to, we're substituting 1 inside here. So we'll get 2 minus 2/3, right? Subtract. Substitute -2, you get -2 plus 2/3. Is that correct?
Yeah, it's correct.
-2 plus 2/3 because we're substituting negative and negative makes positive, right? Now, 2 minus -2, that's 4. 4 minus 4/3, right? That's 1 and 1/3. 4 minus 1 and 1/3 is 2
Mr. Are
and
we
2/3.
supposed to do PEMDAS? So 2
No,
minus 2/3 minus
now,
minus 2
you can just
plus
use a
2.
calculator, man. That's 8/3.
Okay.
Just use a calculator and you're done. You can even use the integral function on the calculator.
Okay.
But remember, change the y to dx, right? Let's see if we get 8/3. So we have integral from -1 to 1, right?
Change the x, no?
No. You can change because the variable and you're going to get a numerical answer. You can't change the dx. You have to change your variable. Remember your variable, it's like you're solving for y variable. You can always choose a different variable. You can even change this to x or whatever. So that's what I'm doing on the calculator. So that's 2 minus 2 alpha x squared. It's just that when you're entering it on the calculator, when you're writing it out, it must be in terms of dy. When you're entering it into the calculator, it should be there, 8/3, okay? Are we good, guys?
Okay, so yeah, I understand. Yeah.
Right, so I've
Why
got the
Mr.?
answer 8 over. Yes, welcome. All right, so guys, so we get an answer which is 8 over 3. Now, I wanted to go over something very important. Can you see this area is kind of like symmetrical? The bottom piece and the top piece are like symmetrical.
Yeah. Okay.
Yeah.
Yeah.
So when you have like a symmetrical area in this case, you can say this integral. Now, how do you know when something is symmetrical or not? See, you have a function. Note. If function is if a function if a function is even, then we know f of negative x is equal to f of x, right? We know it's an even function. So in other words, there's a symmetrical about the y-axis, right? But now in this case, look at this function 2 minus 2y squared. If I put negative y here, it will still become symmetrical. So if a function is even, then the integral can transform like this. Integral from negative a to a of an even function. Let's see what I'm writing. Even function. Dx or dy, whatever, it doesn't matter. Let's put dy or dx, depends what you are integrating over, is equal to 2 times 0 to 1 of the same even function. It's twice, and I cut it in half, right? Because it's symmetrical. dy. So this is something like a trick to integrate. Example. Remember, my function was symmetrical over. Remember, I've got negative a here and a here. Integrating over the entire region, right, is the same thing as saying integrating from 0 to a multiplied by 2. So just say for example, you have something like this, okay? And you can clearly see that the area looks symmetrical, okay? This happens a lot. These types of integrals you find a lot in trig functions, and right. So what you see here is that you can clearly see that this area is symmetrical. Instead of integrating from negative a to a, I can just integrate from 0 to a and multiply it by 2. So I want to do the same example using an even function theory. So I want to take this and I want to resolve this using this even function. So
Wait,
area
Mr., you
is
put,
equal to,
sorry, Mr., you put, if the integration of negative a to a is the same as 2 times 0 to 1, is it always going to be 1? Or is
0
it
to no,
0
sorry,
to a?
0 to
0 to a, right?
sorry about
Okay.
yeah, 0 to a.
Okay.
Right. I was focusing on this integral. Thank you. So what we're saying is that because this function is even, we can say this is 2 times integral 0 to 1, because see this 1 here, negative 8, of 2 minus 2y squared dy. Now, why this helps us? Because we can integrate the integral much more faster, because this is 2 and this is 2y minus 2y cubed over 3.
Mr.
See what
Ghazali,
happens now. Yes.
I
If you
just want to
substitute
ask you
1 inside,
because I
yeah.
need to leave now. When is our next lesson going to be?
Our next lesson is tomorrow.
Why?
Oh, okay, we will discuss it. We'll discuss it.
Mister, it's because I just finished studying lesson 10, critical values today.
It's fine. It's fine. We'll
I'm
discuss
so
it when we go.
behind. I'm very behind.
Okay, okay. It's okay. Don't leave now as yet. Let's finish the lesson and then you can leave. 8 over
When?
3 units.
At 7?
No, not at 7. Just 10 minutes before 7. All right, guys. So I've solved this integral 2 minus 2 thirds. Remember, if I substitute 0 inside here, I will get 0. That's the advantage of doing this, because you got to substitute 0 and you can just omit that. So I've got, when I substituted 1 inside, I had 2 minus 2 thirds. When I substitute 0, I just get 0. So done. 2 minus 2 thirds is 4 thirds. 2 times 4 thirds is 8 thirds. All right, so you learn something new. Okay? When the area looks symmetrical, not when the area looks symmetrical, well, when the function looks symmetrical, how you know when the function looks symmetrical? You got to substitute this and check. Or you also need to check like this, or f of negative y is equal to f of y. This is symmetrical about the y-axis, and this is symmetrical about the x-axis, right? X-axis symmetry. And this is y-axis symmetry. Okay, great. Now let's look at more examples. Now we're just solving problems because my main concept for today was teaching you areas, right? Let's look at question 3. Right, so we have a function which is, all right, it's a split function, is y equals 3 and y equals negative 2. And we're integrating from 0 to 4 and 4 to 8. This is quite simple because if you try to draw the graph, it's good to draw the graph, then you know exactly what you are doing. All right, so from 0 to 4, and you got from 4 to 8. 4 to 8. From 0 to 4, the area is 3, right? The graph is 3, y equals 3. So it's like a split function, that's easy. It's just y equals to 3. I need to just erase off the rest part. From 0 to 4, including 0, including 4, okay? And then minus 2 if 4 to 8. Minus 2 from 4 to 8. From 4 to 8, 4 is not included, 8 is included. Remember the type of discontinuity here at 4 is a jump discontinuity, right? But now we want to evaluate this integral. So to evaluate this integral, you can't just go and evaluate from 0 to 8, okay? Because it's two different functions. So first what we're going to say, integrating from 0 to 8 is integrating from 0 to 4. Now 0 to 4 is which function? 0 to 4 is the 3 function, 3x plus 4 to 4 to 8 is what? 4 to 8 is negative 2. Okay? So this is just going to give me 3x 0 to 4 plus negative 2x. Why I'm saying plus negative 2? Just put negative and plus becomes negative. And 2x from 4 to 8. So if I substitute 4 inside here, I get 12. Substitute 0, you get 0. So subtract. Substitute 8 here, get 16. Minus 8. So I've got 12 minus 16 minus 8, 12 minus 8, which is 4. Right? And remember, this is not an area. They just said must evaluate 0 to 8 of a split function. Okay, so you gotta evaluate it in terms of pieces, piece by piece, because you can clearly see this is in 2 pieces. So your integral must be in 2 pieces as well. Are we good, guys? It's quite simple,
Mister, in this
one.
case, we can't multiply it by 2 and do it that way, right? Because it's not from
No,
negative,
no.
so something to
It's
zero.
a negative. There is no
no.
negative, yeah.
Yeah. Okay.
Yeah. We know that's mostly used for like functions and trying to find area bounded
Yeah.
and stuff, right?
Yeah.
This is
This
very
one was
simple
just
example.
evaluating the integral.
Yeah, it's got nothing to do with the areas.
Yeah. But
It's
Mister, in
just
this case,
evaluating integrals.
we're just assuming that these two functions are equal, right? Like the integration, or they're not equal, but like they have the same symmetry, I guess.
No.
That's why we're adding the two, is it? Or
No. The reason why we're adding the 2 is because these are split functions.
oh,
Remember,
yeah,
these are
okay.
piecewise functions.
Yes,
So you
piecewise
gotta
functions.
do the integral in pieces.
Yeah, in pieces. Okay.
Yeah,
You
that's
can't
it.
combine the two.
No, you can't.
Okay.
Look at this example now. Now, remember, this is where students get caught out because they don't try to analyze the graph and they don't try. Sometimes very simple graphs, you don't want to analyze it and you just want to start solving. How are you going to solve something like this? We got a problem. To solve something like this, absolute value of x, you got to draw the graph and it's a basic V graph. Okay.
Yeah,
If
just
you don't draw,
V-graph here.
yeah, if you don't draw the graph, you're going to be lost. Then you don't know what you are doing, because you can clearly see that this absolute value function is in two pieces. I'll tell you why. See there, you're trying to find the integral from -2 to 4. Okay, so -2 to 4 is from here. There's -2 here, right? And there's 4 there. And then you need to remember the definition of absolute value. So let's call this the integral for now, right? Let's call this the integral. I means the integral. What's the definition of absolute value? Absolute value is x if x is positive and negative x if x is less than 0. So absolute value function itself is a split function. Now, wherever you see an absolute value, whether it's limits or integrals, you got to write it out like this, the definition of absolute value. So now what are you trying to do? I'm trying to evaluate the integral from -2 to 4. So if I didn't draw the graph and if I use this knowledge only, where is -2 to 4? I can't integrate over the entire region because it's two different functions. This is negative x function and that's positive x function. Can you see? So you got to integrate. This integral has to be broken down into two parts, which is integral I1 plus integral I2. I1 integral is integral from -2 to 0 of negative x dx plus, and the second integral is 0 to 4 of x dx. Are we good, guys? Make sense?
Yep, makes sense.
Yeah, right. Now you can evaluate, because now you already set up the integral. Now it's easy to solve. -2 to 0, so that's just negative x squared over 2, -2 to 0. If you substitute 0 inside here, you get 0. And if I substitute -2 here, okay, so I'm getting 0 minus. If I substitute -2 here, I'm getting 4 over 2, so -2 here, right? -2 to 0. Is it -2? If I substitute -2 squared, no, minus 2. Remember, it's upper boundary minus lower boundary. Okay. Are we good, guys? I hope I made myself clear
But
here.
Mr. Isn't it
Upper boundary is 0.
-2 squared over 2?
Yeah,
So
so
-2 squared is 4.
4 over 2 is
negative.
2.
Oh yeah, it is. It's -2.
The entire function value
Yes,
is
yes,
-2,
yes.
right?
Yes.
Remember, this entire thing is a function value.
Yeah.
This is 0 when you substitute 0. When I substitute -2, it is -2 here.
Yeah.
All right, let's do the second part now. We got this answer. The second part is just x squared over 2 from 0 to 4. So now if I substitute 4 inside here, if I substitute 4, I'm getting 16 over 2, which is 8. And substitute 0, I get 0, right? So that's easy. So I've got 2 plus 8, right? Which is 10. Let's try to check on the calculator if we actually get 10 as an answer. So we can do it negative. We can do from -2 to 4 of absolute value of x. You know how to put the absolute value function. Let's see, where's the absolute value? Maybe I can't see it.
So it's shift HYP. So next is to the left of sign. Shift that. Shift left of
Shift,
sign.
yeah, got it. Alpha x, right. I hope they'll be able to see.
Yeah,
Check.
there we go.
They got an answer of 10.
Mm-hmm.
Right, because remember, you can't integrate absolute value function. You got to break up the absolute value and integrate it over its different regions. Looking at the next problem, guys. Last problem. Question 5. We want to find the integral from -3 to 3 of 9 minus x squared. Okay, does anyone know how to do this?
Is there some specific formula for doing with the
So we
roots,
use
like
the power rule, right?
absolute?
No, very good.
We use
But
we use
remember,
the power rule.
remember, first thing, whenever, what is an integral? It's basically finding the area under a curve. So let's try to analyze this curve. Let's just say, okay, this curve is y equals square root of 9 minus x squared. Okay, what if I square both sides? Then I will get y squared is equal to 9 minus x squared. Okay, what if I bring the x squared over? And I get x squared plus y squared is equal to 9. Ah, then you remember,
circle.
okay, this
Yeah.
is an equation of a circle with center, center
Center
0,
of 0,
0,
0.
center
And a radius of 3.
0, 0, radius is equal to root 9, which is equal to 3, but not actually a circle, it's a semicircle.
It's just
Correct.
semicircle. Yep.
It's a semicircle because top half of the semicircle, very important because square root positive.
Mhm.
Remember, the entire circle equation is this piece here. This is the entire circle equation, or the bottom piece here. This is circle equation. And now, obviously, the top part is the top half, which is the semicircle equation, right? Now, this entire piece is very important because you see the top half is that's what we are finding. We're trying to find the area of this top half. And that's the equation that is represented. If I ask you, what's the equation of the bottom half of the semicircle? It's going to just be with a
It's the
negative.
same. Yeah,
It's
it's
the same with a
negative.
negative in the front, right? Great.
Yep.
So now this was 0, right? I need to take out the rest of the curve. It's not part of the graph.
So can't we just use the circle area of a
Of
circle?
course, of course. You have
So
got to
pi
use
r
geometry.
squared. So it's pi
Yes.
over 2r squared.
Yes. So this is -3 and that is 3. So
Yeah.
what's the area? Area is just basically equal to the, remember, if we call this the integral, so because they said evaluate, we really don't know what that is. So we're just going to say the integral is equal to the area, which is pi r squared divided
all
by
over
2. Yes. And when r is equal to 3.
3.
Yep.
It can also equal -3. So plus
No.
minus 3.
No,
Oh,
radius
no,
is
it can't.
positive.
Yeah,
Positive is
yeah,
radius,
radius is
right?
always positive.
Yeah, in a equation of a
Yes,
circle.
yes,
So,
yes.
so r is equal to 3. Put 3 there. 9 over 2 pi.
9 over 2 pi.
Great. Now we have a problem. We will end up with a problem if they try to do something like this now. See? Then you got a big problem. Then you have to use the forms that Farooq was talking about, which we are going to learn during the course of this week. Note, this integral is difficult now because we managed to identify this as a geometrical problem. It's quite simple. Now, if you put from -2 to 2 or from -2 to 3, then you got a problem.
Okay.
Let's just say from -2 to 1. So now if you try to find the area from -2 to 1 of square root of 9 minus x squared dx, then you got a problem because you need to look at the different forms. Right? And this here becomes like a trig integral. You have to transform it to trig integral, which is quite exciting to do, right? Because we're going to end up proving this as well, that we get the same answer, and then we start doing stuff like this, right? Okay, guys, we can end off now, and wait, I'll take questions
Already?
after I end off
Okay.
the video. Wait 1 second.